All right, everyone. So let's look at another example, a more complicated example. So let's say that we have this demand function, 200 minus 3x. So every additional unit that we want to sell, the price is going to go down by 3. Or conversely, if we want to increase the price, we're going to have to sell fewer of these things. And now we're actually going to talk about cost and profit. So previously we were just talking about revenue. Okay. So for revenue, what we had is that we just looked at how many things are we selling and what is the price that we're selling them at. That was the revenue. For profit, it's just going to be revenue minus cost. Okay. How much are we making? How much are we spending? That's going to be our profit. So this is going to be pretty similar, but just be a little careful because again, profit is going to be our revenue minus our cost. When we're subtracting our cost, we're subtracting this entire function. So when you subtract out the cost function, make sure to distribute that negative. Okay. Anyway, our revenue is just like it was before, right? How many things are we selling? What price are we selling them at? Minus the cost function, which is this whole thing, 75 plus 80x minus x squared. And again, be very careful here. You have to distribute that negative to everything. Finally, we'll replace p. P we said is 200 minus 3x. And then it becomes minus 75 minus 80x plus an x squared when we distribute that negative. And then we'll distribute collect like terms. We'll be good to go. I don't know why one of my distributes is green and the other one's red, but I'm sometimes festive. 200x minus 3x squared minus 75 minus 80x plus x squared. We'll combine like terms. Minus 3x plus x. That's going to be a negative 2x squared. Right? And we also have so minus 80x kind of by itself. And then minus 75. Oh, no, it's not. Minus 80x and a 200x. That's going to be 120x. All right. All right. And the last term is going to be the minus 75. So this is our profit function. Our profit function is a downwards parabola. Right? It's a quadratic with a negative leading term. We want to find the maximum. So let's look at the derivative. Derivative of this profit function is negative 4x plus 120. Local extrema will happen at critical points, which is when the derivative equals 0. Solve this real quick. You'll get x is equal to 30. And remember, be very careful for this problem. We do have a domain right here. This is our domain. It's our restriction. That we can't just produce 5,000 units if we want to. We can't produce negative 3 units. We can produce 0 units. We can produce 40 units and anything in between. We can't do more than 40. All right. So if we found that a critical point occurred at a production value of 50, well, too bad. Our manufacturing capabilities don't let us. Okay. Or maybe some kind of laws are preventing us from increasing production past this point. All right. This is too much color on here. Go down to less color over here. So this is in the domain, which is good to check. So again, we do have a domain right here, but we found the local extrema. And it is a quadratic, so it will be an actual maximum. All right, so we found, what is the problem asking us to do? Find the values of x and p that maximize profit. Well, this is the production level that maximizes profit. So we just have to plug this into our demand equation. Our demand equation is 200 minus 3x. So to find out what the corresponding price is, we just plug in 30. All right. So that's going to be 200 minus 3 times 30. 200 minus 90 is 110. So we need to produce 30 units and we're going to sell them at a price of $110 each. That will maximize our profit. So finding that sweet spot where revenue is as big as possible and cost is kind of as small as possible, that balance is what we do. That's part A. But there are other parts. Let's do part B. Let's say a tax of $4 per unit is imposed by the government. Find the new price that maximizes our profit. So our cost of production is going up, right? If we have to pay the government $4 for every unit, our profit is going to go down by $4 per every unit. Let's write that down. The profit goes down by $4 per unit. This is going to have a different maximum. Let's revisit our profit function from earlier. Our profit function from earlier is at the top of the page here, negative 2x squared plus 120x minus 75. That was the old profit function. But we're also losing profit for every unit we sell. We have to pay $4 to the government. We sell 1 unit, we have to pay them $4. 2 units, $8. 3 units, $12 to the government. So we're losing $4 for every unit that we sell. That's what's getting taxed. So that's how our new profit function looks. It'll still be negative 2x squared. But now it becomes plus 116x minus 75. And we just find the local extrema here. We'll do all the same steps. I'll go through it kind of quickly because it is the same steps from part A, but I'll have them down for you. We find the derivative, negative 4x plus 116. Set it equal to 0. Solve it, and you should get 116 divided by 4, which is, oh my word, my calculator is failing me. $29. Thank you, Google. Would have been just faster if I did it in my head. But again, so let's look at this, right? If there was no tax, we wanted to produce 30 units at $110 each. With this tax, we actually produce fewer things. If there's a tax, our profit is maximized at a lower production value or production level. But again, wait, that looks like price. It really is price, by the way. That's like the top of the I. That looks kind of weird. All right, find the price. So again, we'll just use the demand function. So if x is 29, our demand function was 200 minus 3x. We're producing 1 fewer thing because of this tax. Type that into our calculator. Let's see if I can get it this time. 200 minus 3 times 29. 113. So we used to be selling 30 units at $110. With this tax, we're now only doing 29 units, and we're charging an extra $3 per item. So the government is charging us $4 per item. We're passing on 3 out of the $4 of that tax to the consumer here, is what we say. Okay. We have to produce a little bit less, one fewer of these units in order to maximize our profit, but we can charge more because we're not selling as many. Government's charging $4, passing 3 of those dollars on to the consumer as part of the price, which is something that happens with taxes. Okay, let's look at the last part here, part C. Let's generalize part B. Let's say the tax is T dollars. Capital T dollars. All right. Find the price that maximizes our profit. So this is going to be very similar, just now instead of, right, we almost take the same profit function, but instead of 4x, it's going to be tx. All right. Our profit is going to be negative 2x squared, just like before, plus 120x, just like before, minus 75, just like before, but now we're losing T dollars for every X to taxes. So instead of $4 for every X, it's T dollars. Let's say we don't know what the tax is. We can solve this again, same way. Find the derivative, set it equal to 0. And then solve for X. So we'll add 4x to both sides. 4x is equal to 120 minus t. Divide both sides by 4, and we're going to get 30 minus t over 4. Or 30 minus 1/4 the tax. When the tax was $4, right? When the tax was $4, production fell to 29. If the tax were $8, production would fall by another unit, and the price would keep on going up accordingly. All right. This problem is asking us find the price that maximizes our profit. Let's plug this into our price function, our demand function. 200 minus 3x, and x is 30 minus 1/4 t. Just simplify this and we'll be good to go. 200 minus 90, distribute that negative 3, so it becomes plus 3/4 t. Combine like terms, we'll get 110 plus 3/4 t. So this, remember when I said, if we have a tax of $40, it passes 3 out of those $4 onto the consumer. That's true for any tax. So any kind of tax that we get, so this is in dollars. This is going to be the price. Any tax that the government imposes on our production, if they have this excise, we call it an excise tax. If they give a tax per unit, so a flat fee that we have to pay the government per unit that we produce, the price increases by 3/4 of that tax. So what we say is that if the government taxes us here, that we're putting 75% of that tax, we're passing 75% of that tax onto the consumer here. That's what the interpretation is at this point here. Any tax that they choose, 3/4 of that tax is going to the price, is going on that sale price, that shelf price or whatever that we're that the customers are going to have to pay. All right. That's what's going on here. Good luck. Maybe I should just add all of these videos, end all these videos with good luck, like you're gonna die or something. It's not that bad. Math is good. Let me know if you have questions. Bye bye.